Hey, what's up you guys, my name is Harrison and welcome to School of Swipe. So today we're going to be talking about conics, and since this is a slightly smaller topic, I'll just be making about 2 at most 3 videos about this. So the contents are pretty straightforward. What are conics, flowchart, and equations and how to deal with them. So conics is short form for a conic section. So basically you take a cone and a right angled cone, and then you just like slice off a bit of it, and then when you slice it off it actually forms an equation. So there are 4 types or 3 types of equations that you can form. So some people consider circle to be a type of ellipse, so and some people consider circle to be its own special kind of equation. So there you have either 3 or 4 equations. So the first thing you need to do is identify the conic. So sometimes they may just give you an equation, and just by looking at it you have to identify what kind of shape it is, and hence sort of you have to know where you're going and what formula to use when you're thinking about how to manipulate that equation. So here's the flowchart. So it starts off with, does the equation have both x squared and y squared? So it bunches of yes or no. Just treat it like a flowchart. PowerPoint isn't the best at creating flowcharts. So let's just put this into practice. So we have a few equations here. So the first thing we can do is look at this one. So 2y squared, there's a y squared and an x squared term. So there's that. So are the x squared term and the y squared term, okay, these are both positive, so this is the equation for an ellipse. So when we look at the second one, we have a y squared term and we have an x squared term, but the y squared is positive and the x squared is negative, so it's going to be a hyperbola. So when we look at this one, we see x squared term but no y squared term at all, so this is going to be a parabola. X squared, y squared, but one is positive, one is negative, another hyperbola. And this one, I put this in here just to show you that you have to put, like, you can't just look at it and say, oh, this is like positive, this is negative. You have to notice how all this is 0, so you have to push it all to one side. So actually this is an equation for a circle. When you see x squared and y squared, they're actually both positive at the same time. Okay, so here are the answers again. So let's go into circles. So circles have a formula of this basically, and the r is a radius, so you can see r squared here, and the center is hk. So notice how this 2 is both negative, right? So if you see x plus 2 squared plus whatever, so it's plus 2, so h is negative 2, so you have to be careful of that. So your center will be like minus 2 something. So let's just check out the demo on desmos.com. I really like using this website for stuff. So this is the circle. So as you can see, as r gets bigger, the circle gets bigger. As r gets bigger, the circle gets bigger. As r gets smaller, the circle gets smaller, which is pretty straightforward. Notice how it's minus a here. Okay, so as a increases, it goes to the right and it goes to the left, which is pretty straightforward. And when b goes up and down, the circle also goes up and down. So yeah. Okay, so yeah, if they just give you an equation and they want you to graph it out, so here are just like a few steps. So you have to, first thing you do, use a flowchart, just identify what kind of equation it is. So in this case, when we see x squared and y squared, we can just identify it as a circle right away. Hence, we will know what standard form to use, and the standard form for circles is this, x minus h squared plus y minus k squared equals to r squared. So if you see something like that, the first thing you gotta do is complete the square. So after completing the square, you just put it in your standard form. I won't be going through step by step on how to complete the square. So yeah, I have another video on how I did it, but this is just conics. Okay, so this is standard form, and from here you have to remember, if you see 13, the radius isn't 13. You have to square root 13 and then put a square there. So the radius is actually square root 13, and the center of the circle is 2, 3, which is this graph that you see over here. Okay, so the next one we're gonna try is ellipse. So ellipse is similar to a circle. So if a equals to b, then you can just multiply both of it up there, and you actually have your circle equation. And this thing will just become an r. But yeah, basically an ellipse is when the so-called horizontal radius thing is different from the vertical radius. They actually have a different term for it, but it's I don't like the other term, so even though it's not mathematically correct, I call it the horizontal radius and the vertical radius. Okay, anyway, let's just go through the demo. So we have H and K as normal, which is this is the thing that would this is the center. So when H increases or decreases, it goes left and right, and this goes up and down. Okay, so you can see it's basically the one right next to your X or right next to your Y, right? So these will control whether they go up and down. And A square is, as you can see, is right next to X. So if it's next to X, it's probably something to do with the horizontal axis, and if it's next to or close to Y, it's something to do with the vertical axis. So like I said, H is near to X, so it's something horizontal, right? And K is next to Y, so it's about the vertical axis. So A is near the X, so it's about this horizontal distance. So it gets smaller, or it gets thinner, or wider as A increases or decreases. And for B, it just gets like taller or shorter, yeah, something like that. Okay, and that's about it for ellipses. Other than that, it really resembles a circle, except that, you know, the horizontal distance and vertical distance are different. Okay, so yeah, the rules, the method is the same. You just identify what kind of conics it is. In this case, you say ellipse, and then change it to standard form, and then you graph it. So so again, y square and x square are both positive, so it's gotta be either ellipse or a circle. And then we complete the square, and then you have to put it into standard form, which means you have to put your 32 over there and then divide everything by 32. So in the end, it kind of looks a bit like this. So the horizontal distance radius thing from the center, okay, is square root 32, and the vertical distance is 14, and the center of the ellipse is minus 1,3. Alright, so let's just look at hyperbolas now. So okay, horizontal or vertical hyperbolas. You know what? Actually, I'm going to take a break from this video, and the next video we'll just start at hyperbolas onwards. So, you know, thank you guys for watching, and I'll see you on the next video. Bye.